there are some people in the room over that can help with that part of things. But if you want to dig around your email for the participant coupon code for Nobari, that would be helpful to do now.
The nice thing about Nobari is it will have the same notebooks that we're working on provided.
this is the tutorial on data visualization with Vega-Altair. Thanks everyone for coming. We're going to start with getting things set up in Nibari. Nibari is the online cloud notebook environment that Quantsite has provided for tutorials. It's made it a lot easier for us to use the same versions of things and get the same notebooks. So there was an email sent to tutorial participants. I think it's titled something like installation instructions for tutorials. You can search for that or search for Nibari in your email. This user guide should be in that email. And one thing you'll need to find is a coupon code that'll be listed there. That I don't have that. This is different for the participants. Is that all it is?
I mean, I'm assuming why it's not unique.
Okay, all right, perfect.
All right. SciPy 2024, all caps.
Yeah.
Okay, all right, perfect. All right, we'll walk through that. So when you go to SciPy Quantsite Dev as the starting point for logging into Nibari, my account is already logged in here. You'll go through the sign-up flow with your email and then the SciPy 2024 code to get your account logged in. Just let me give folks a moment to work on that.
Yeah, so maybe should they try to get to this same screen you're on? Should that be the goal?
Yes.
So John didn't have this screen, but this is what it looks like for me when I go to Nibari. And then I sign in with KeyCloak and use the email address and password I chose.
And from here, we're going to go to Jupyter Lab as the quick access starting point. If you haven't done this before, it'll ask you for the instance that you want to use. A small instance is fine for this tutorial. Yeah?
If I didn't get an email,
What's that?
if I didn't get an email, how do I get there?
So go to scipy.quantsite.dev.
And I can't quite remember what registration looked like, but was it clicking this register here button or link?
I believe so.
Yeah, so on that site, John said there's a link that says register here. I think that's where you use the coupon code. I think that you should choose that when you register, I believe.
Could you raise your hand if you've gotten to this point of Jupyter Lab logged in? Okay. If you're stuck, there is in the next room over, there's a group of people that are working on like getting people set up with different things. So if you do get stuck and can't figure out the next step, yeah, go ahead. Where are you stuck? I think that's SciPy 2024, all caps. All right, I'm gonna move forward. If you're still having trouble, I recommend just jumping out quick to the next room over and asking for just help with Nibari setup. The next part towards getting going with this is from the Jupyter Lab launcher screen. There are these tutorial repositories section. And you can download the notebooks for this tutorial. Just click the download button. And what that does is it drops this tutorials directory in your instance file system. Navigate into tutorials. You'll find the directory for our tutorial, the Altair tutorial. And then this is what we want to get to. These are the different parts of the tutorial and our resources for like the test sample files we'll use for different things. All right. So going to part 0, just want to introduce what we're doing here. This is an important piece. Each time you open a notebook, it's going to ask you what kernel you want to use. The kernel that is configured for our tutorial is the Vega-Altair tutorial environment. Oops, that jumped way too fast. So choose the Vega-Altair tutorial environment that has the dependencies we need for our tutorial, and that should be all we need to move forward and get going on the instructions. All right, so this part 0 was some summary of the Nibari part of things. Taking a step back, so I'm John Mease. This is Chris Davis. We are both maintainers of the Altair Python library along with several other folks. We have different backgrounds. I'm a visualization engineer with Hex Technologies. Hex is a company that builds a data science platform and uses some of the same core visualization technologies that Altair is built on. Chris, introduce yourself.
Sure. Hey, I'm Chris. Thanks a lot for coming to our tutorial. I work in the math department at UC Irvine. I have a teaching-focused position, and I've taught a number of programming courses, and those in the math department, like related to data science, and those courses are sort of what moved me towards Altair and getting involved with its development.
So this tutorial is broken up into 4 parts. We're going to walk through some of the very basic syntax of Altair and how data gets mapped or encoded into different visual properties in your charts. We're going to look at data transformations. Altair has a very rich set of data transformations you can do inside your charts that's very useful for different kinds of aggregates. And also, as we move into interactivity, Altair has a very sophisticated system for building interactive charts that are independent of Python after you create them. They're shareable, and in the next section we'll talk about how you can share Altair charts in different formats, both statically and in an interactive form. And then we'll end up with each of these sections we have some exercises, and then during exercises we'll be around to walk around and talk to people about what you're doing. And at the very end we have a more open-ended exercise when we want to help you with any data sets that you've worked with in the past, and help you work through the process of sharing a visualization with other people. Chris is going to get started going through this part 1 section, and we'll be jumping back and forth as we go. So here you go, Chris.
Okay, great. Yeah, thank you, John. How is this font size? Should I make it a little bigger? Is it okay? A little bigger? Is that okay if I? And maybe I can make the directory a little smaller.
Yeah, you can collapse
So
that.
John is the one with the programming expertise? Okay. Okay, is that better? Okay, awesome. Yeah, and if I'm going quickly or anything's not working right, please just interrupt me. I prefer interruptions to this. And our part 1 is a little bit different from the other parts. I have some cells that are blank that I'll try to fill in as we go. And then, yeah, we'll see how that works. If it doesn't work well, the filled in version is here in the completed directory. But in general, I prefer adding some stuff as we go. So the main goals of this part 1 are to get familiar with the Altair syntax. So like when I first started looking for what visualization library I wanted to use in my teaching, I sort of instantly liked the look of Altair a lot, but it definitely took me a little while to get used to the syntax of it. And so one of the big goals of part 1, both this part and the exercises afterwards, is just to get a little more familiar with those components that go into making a chart in Altair. And there are different encoding data types, like for numbers versus categories in Altair. So we want to talk about those a little bit, and we want to talk some about how you customize chart appearance. So let's see if this is working. Just going to execute some of these cells as we go. Okay, seems to be working. And just as an example, I'm going to start with this little 4-row pandas data frame. And yeah, Altair can work with other types of data frames like in polars, but most documents that you find on the internet will use pandas data frames. And so here's just a little tiny 2-column, 4-row data frame that we'd like to visualize. These 2 columns called category and value. And so just sort of want you to take a minute and look at these next, I think, 4 charts that we have, sort of think about how they're similar, how they're different among these next 4. Or 5, I guess. So just take take 30 seconds or so and look through those and think about how those charts might all be created out of this same data frame and what the similarities or differences are among these 4 charts or these 5 charts. Anyone having trouble accessing this stuff in Nabari? Sort of the main things that are used here, not so much the category column, it's really this 2, 2, 10, 4 value column that's getting used in these charts. So like just among these first 2 charts, what's one of the main differences between these 2? Yeah, they're sort of transposes of each other. So in one of these, the value is corresponding to the y, like how far up it goes in the y direction, this 2, 2, 10, 4. And in the other one, that's corresponding to the x direction, how far we go in the x direction, 2, 2, 10, 4. I'd say there's another huge difference between these 2 that's maybe so obvious you're not even thinking about it, but what's the other big difference between these 2 charts? Yeah, line versus bar. And so when you're making an Altair chart, one of the things you choose is what type of mark do you want to use. And so this first one was made using a line mark. Second one was made using a bar mark. And yeah, you can see the code for these if you want, but I don't necessarily recommend it. I did some things like remove axis labels and things like that, which isn't really part of what we were trying to convey. So this one also encodes 2, 2, 10, 4 in it, but there's just one dimension of the data. It's just saying this is far we go in the x direction, and there's really nothing getting encoded in the y direction. And yeah, at least for me, it came as a surprise how like a pie chart can sort of be thought of in the same structure, like 2, 2, 10, 4 for the like proportionally giving the sizes or the arc sizes of these sectors of the chart. And another one, this one, the distance between like 4 and 10 and 2 and 4 is different. Like up here we see this bigger distance between 2 and 10 versus 10 and 4. 10 and 4 are closer to each other. But here, it's only the ordering that's getting considered. It goes 2, then 4, then 10. And so this is another way of encoding or of making a visualization from this same little chart. So that's just kind of a warm-up of thinking about how these different values in the data frame get encoded into visual properties of the chart. Okay, any questions before I go on to the next section and start doing some coding? Yeah, part of the reason for that was just so that, like, you had to think visually about, oh, we've swapped category and value, rather than like seeing category and value written next to the axes. That was sort of what I had in mind. And yeah, out of curiosity, how many of you have worked with either Plotly Express or Seaborn before? A lot of, like, the little syntax will be different in Altair, but the ideas I was just talking about of encoding columns in the data frame as visual properties of the chart, those should be very familiar from Seaborn and from Plotly Express or from ggplot, if you have experience with any of those. Okay, so here is the live coding part of the tutorial. Just going to show you how to make a little Altair chart. So if I do alt.chart just by itself, should get an error. Yeah, so here I get an error, and we've tried over the years to make, I'm not responsible for any of the improvements, but maintainers have tried over the years to make the error descriptions a little more readable. This one is on the more helpful side. It says mark is a required property. So it's like how we were talking about this mark bar versus mark line before. I need to specify what kind of mark we're using in the chart. So alt.chart and then how about mark circle is the one I use most often. This is the one I use if I want to make a scatter plot. Okay, so there is our first handmade Altair chart. It's this little chart that has a single circle in it. So that's what we're starting with. And I should mention, I have this written somewhere. Yeah, a lot of what we do today will not work if you're on Altair version 4 or earlier. So I think earlier you needed to explicitly pass a data frame. And in almost all real life situations, you'll want to explicitly pass a data frame, but you don't always need to. And so this is an example where we haven't said what data to use. And Altair is fine with that as of version 5 or 5.1 or something. And so let's see, if we scroll back up to the imports section, one of the parts was from Vega datasets import data. And that's just going to give us access to some toy datasets that we'll use throughout this tutorial. And yeah, I should maybe say, and John might be able to speak more intelligently about this than I can, but the sort of overall ecosystem is there is Vega, which is a JavaScript library based on a JSON specification, if I memorized what John told me earlier. And then, but it is fairly like wordy in terms of making charts using Vega. And then there is a more succinct version that's still from JavaScript or from TypeScript called Vega-Lite. And both of those are very connected to University of Washington up the road from here. And then there's a Python version of Vega-Lite, which is this Vega-Altair that we're using. And when I think of it in my head, I think of it as Altair, not Vega-Altair, but the formal name is Vega-Altair. So we'll sort of move back and forth between those two. But they're all part of the same ecosystem and all in the same GitHub organization. Okay, so that was about the data. And so here, this is an example of using that data that we imported from Vega datasets. Here we're going to get the cars dataset. And these are mostly fairly small datasets. This one, I think, has about 400 rows in it. And just to show you what what it looks like has these different columns. And one reason I like this data set is we really want data sets that have different types of columns. So this one has some integer columns, some float columns, like real number columns, and some string columns, and also a date time column. And so, yeah. Okay, so here, like up above, we didn't pass any data frame, but here we're going to pass this, this cars data frame df. So alt.chart. Okay, and then inside these parentheses, when we're creating this Altair chart, I just pass df to say what data we'd like to use. Then I'm going to do mark circle like before. Okay, and then something new that we do is dot encode. And here I'm going to say what columns in the data frame should correspond to what visual properties in the chart. And so here to start with, I'm just going to use, okay, and this comment was here for me because when I'm like making a chart to start with, I tend to write it like this, but it's a little more robust to write it like this. Alt.x. And so that's like telling Altair this is going to be how the x position, like the position along the x coordinate, gets encoded. And so if you look at the Altair documentation, you will often see x equals weight in pounds. And that's fine if you just want to encode it and do nothing else. But if you want to customize the appearance later, then it's better to use this alt.x, because there's no way to like customize, for example, what domain of values do you want in your chart. There's no way to customize that if you're using this string syntax. Okay, and so let's see how this looks. And so how you should picture this is that it's like one of those sample charts we saw before where we're not encoding the y position at all. We're only encoding the x position. And so each of these circles that we see here corresponds to a different row in the data frame, and all we're getting from that row is what's the weight of that car. And yeah, certainly some of these might be plotted right on top of each other if two cars have the same weight. And by default, these have an opacity of something like 0.7. And so in general, the less opaque it is, the more of these circles you're seeing like plotted on top of each other. Whereas if they had an opacity of 1, then 2 on top of each other would look the exact same as 1, just a single one. Okay, so just here I have, if there are 400 rows, I probably have 400 circles here, some of them plotted on top of each other. And each circle corresponds to what's the weight of that car. Yes?
Is there a way to make the graphic bigger in the notebook?
Yes. Oh, interesting. So the question was, is there a way to make the graphic bigger in the notebook? And so what comes to my mind, and John can jump in, is to do dot properties and then specify a width. So for me, it looks pretty good just by default, but I believe these numbers you type in here are pixel values. So I think this is like saying, give me a 600 pixel wide chart. And you could also do height as another keyword argument, same kind of way. Yeah, hopefully that makes it look better. I mean, I'm not sure why the default would be small.
High DPI screen, maybe?
Okay, yes, yep, that makes sense.
Factor of 2 between what's projected. Oh, but you're zoomed in here too. Okay, yeah, never mind.
Okay, yes, yeah. So the suggested issue. If anyone's having trouble with Nabari, we have a helper in the back who might be able to help. But I think everybody's doing well with Nabari. Yeah, thank you. So the suggested reason mine might look different from yours could be a high DPI screen. Okay, let's go back. I'm gonna get rid of the properties here. And now let's add a Y position encoding. So alt.y miles per gallon. And so presumably this has the same number of circles drawn as the previous one, but now there's a y encoding in addition to the x encoding. And y encoding comes from miles per gallon. So there's no way to make like three-dimensional in the traditional sense charts in Altair where you have like an x, a y, and a z position. But we can certainly encode many more columns as visual properties. And so that's definitely one of the fun things about Altair. So like next, one of the most common ones other than x and y is color. And so here I'm going to do alt.color. And like, yeah, I guess here let's do origin. And there are only 3 different origins for these cars in this particular data set. It's like USA, Europe, and Japan. And so here we have the same x and y positions as before, but now the points are colored according to the origin. And I didn't have to specify what kind of color scheme to use or anything here. This is the default color scheme that gets chosen. And so I'm sure I'm going a little slower than intended, so maybe I'll go to the next one, which originally we had thought about saving this until part 3 because it's really an instance of interactivity, but it's like a simple instance of interactivity, so we decided to include it already in part 1. And so here I'm going to say tooltip equals, I'm a little indecisive about whether I want to use this keyword syntax or not, but let's try it with this one. I think this is more consistent with what we do later. Okay, and so what did that tooltip encoding add? So remember that each of these circles corresponds to one of the rows in the data frame. And so this tooltip is going to give me access to the weight and the miles per gallon, which I can already kind of see. For example, this red one here, that one should correspond to about 3,000 pounds and about 37 miles per gallon. Okay, but I can also learn something new. I can also learn what's the name of that car. And so there we can see that this was an Oldsmobile, this car. And one of the nice things about Altair is that once you make this kind of chart, you can include it, for example, in a website, even if you don't have a Python kernel running in the background, and this kind of tooltip will still work there. And so let's see, I'll go on to one more, and then I'll see if there are any questions. It's like when I first learned about this stuff, I thought, oh, well, awesome. I have so many options for what to do. And let's see, since I wrote this tooltip as a keyword argument, I think it's important that I do these next ones before it, because I'm going to do them as positional arguments. But if I wanted, I could do color equals alt.color origin if I wanted to turn this into a keyword argument. So it's not too essential.
Could you also do an alt.tooltip?
Yes, there's one special case later in part 3 that would not quite work with that, which is why I was a little ambivalent about how to do it here. But I also could have done alt.tooltip. Yeah, we can talk about that when we get there if John or I have anything intelligent to say about it. So horsepower for size. And year for opacity. And like always, it's important that the way you capitalize these exactly matches what I do. So here I'm capitalizing and using these underscores to match what are the columns in the data frame. So I think what I was saying was when I first met Altair, I thought, oh, well, the more things you include, the better. But I definitely think it starts to get worse pretty quickly. And so here we have a lot more information included, but I personally cannot learn anything extra from this stuff. But like the size of the circles should indicate something about the horsepower. So like this one should have a lower horsepower than this one, for example. But the reason to go to this was just to show some of the options, not to say this is a nice chart. I think this is a pretty nice chart. I think this one is not a very nice chart. Okay, so before I reset a little bit, any questions about any of that? Yes?
My question is, are you able to, like, we've been basically copying, I at least was copying and pasting the commands and then adding the extra arguments. Is there a way that you could have given that like an object name so that you could just, you know, use that name and keep going instead of having to basically copy paste the?
Oh, yes. So I believe, if I'm understanding right, I think we could have done chart equals this to get the whole thing, and then I could just do another encode method at the end of it.
Yeah, that's exactly what I was asking.
Yes. Yes, great. And at first I thought what you meant was, could we give a variable name to like this alt.x, and we could also do that, but I think this way with chart and then just secretly having a couple encodes towered upon each other is better. Yes?
My question is about the software tools namespaces. So do you know if there is a specific design choice for not accepting these arguments in the mark circle or the immediate visualization function and asking them in the end code?
Oh, okay, great. Yes. So John can get ready to stand up. But the question was, what was the design choice in terms of these things living in encode versus living, for example, as an argument to mark circle, where I could put something like just as an example of what can go there, let me get rid of that size. I could say like size equals 5. Remember that these are pixel sizes. Oh, yeah, thanks. So question was about this. Do you have anything to say about that, John? And let's see, I'll get rid of the size.
Yeah, so the options that you have inside, let me go to a simpler one here. Inside like mark circle, you have access to all the same channels, like X, Y, color, size. But these are, the values for these options are gonna be in what we call like screen space. So these are like literal colors like red, green, blue, not mappings to columns in your data set. So things that you put, so things you put here, are gonna be in like literal screen space, no mapping, no scaling. So if it's gonna be fixed for the entire data set and it doesn't vary based on the row, then you can put it in that mark location. Say that again?
If you put your arguments into the immediate visualization function, you cannot get the values coming from data variables. Rather, you have to give them scalars.
Correct. Yeah, they're scalars and they're independent of the data itself. And that is the reason that the API separates these two things. It would be possible to group them together, and so we've had discussions about whether we should like have these two concepts in the same method. But they do such different things that so far we've settled on keeping them in these two separate locations.
Are there namespaces other than mcode that we will be seeing throughout the tutorial today?
Like we saw properties briefly for that height and width.
Okay.
Yeah, there's some configure. There are some ways to configure like global axes properties that we'll talk about a little bit in the chain as well.
Just for some public housekeeping, when would be a good time for me to be done with part 1, would you say? Like not counting the exercises?
Probably like 45, like another 7-8 minutes.
Okay. Yeah, I'll try to move a little more quickly through this. this next part, but a lot of this stuff, at least for me, I learn these kind of things better when I'm doing them myself, and the exercises are meant to go through these things in this notebook. Okay, great. So let's keep going down here. See, I think maybe I'll just skip some of those for the sake of time. That was about saying when these get layered on top of each other, which one gets put at the top. But I think that's fairly minor in the scheme of things. So let me scroll down to here, the effect of data types. So this is an interesting aspect of Altair. Okay, great. I'm glad to see that this is still working. So this is what we were looking at before. This is the less busy version that didn't have size and opacity encoded in it. And so let me copy that. And yeah, this one I think we could also have done with assigning it to a chart variable and then doing encode and just overwriting the color encoding. But this is how I've sort of been planning on it. So here I'm going to change to cylinders, which in some ways is kind of similar. I think there are 5 different values of cylinders, but we're going to see that things will look very different. And so there's this huge difference where here there are these 3 like fairly distinct colors of a reddish, a bluish, and an orangish color, whereas here they are these different shades of blue. And so the huge difference here is that the data type of the cylinders column is numeric. And so Altair by default is deciding that we want to use what's called a quantitative encoding type for this. Whereas up here, the data type was, they were strings in here. And so Altair was deciding that we wanted what's called a nominal data type. So it's saying there's no sense of ordering, there's no sense of distance between these things. We just want whatever colors clearly distinguish 3 different values for us. Whereas here there are only 5 values, but this would work equally well if we had 1,000 values. 1,000 numeric values, these different shades of blue would still work fine. And so I won't say too much about this, but just like under the hood, Altair is deciding that here we want to use a nominal encoding type. Here it's deciding that we want to use a quantitative encoding type, and it's making all sorts of other choices also. And so just to show you some of those options, and I think John will go through some of this also, is this, yes?
Can you override, like if I want to show cylinders as like a category type?
Definitely, yep, we'll see that in a second, yes. If you want to show cylinders as a category data type, we'll explicitly specify nominal data type encoding in a second, and then it will look more similar to the origins version, yes. In general, you can customize these things pretty much as far as you want, and just to show you some of the many choices that Altair is making under the hood is this is what remember I said that it goes Altair to Vega-Lite to Vega, and Vega-Lite is like a less verbose version of Vega, where I don't mean anything technical by verbose. And so this is what the underlying Vega code is, like the most low-level code. So yeah, I don't think I'll say anything about that, but like, for example, we never told it use an opacity of 0.7, but down here you can see this 0.7 getting chosen somewhere along the way, I think by Vega, if I understand right. And so back to the question from a minute ago, which was, what if we want to treat cylinders like categories rather than like numbers? So how can I do that? So this is the default one, and there are 5 different data encoding types. The default one, when it's a numeric column, is quantitative, so this :q. And so that should not have made any change to the chart, adding this :q. Hey, but if I come down here and I change to :n, okay, then this is the answer to the question from a minute ago of here these are nominal. Here it's treated like nominal, a nominal data encoding type. And you can click on this reference link to see other options. There are 5 total ones. Another one that would be reasonable to do would be what's called ordinal, which is like saying they're still categories, but now nominal means unordered categories, ordinal means ordered categories. And so this looks quite similar to the quantitative version, but notice the difference in the legend that gets created. Here it's just saying we have these 5 different categories, and it's not like adding any extra space between 6 and 8 to say there's a gap of 2 between those. Okay, whereas here it's showing this continuous scale of colors from 3 to 8. And yeah, I think one of the most common types of customization, like in my teaching, the first time we really need to switch to this alt.color or alt.x syntax as opposed to the x equals string syntax is for what I'm going to do here. Let's see. So here I'm going to explicitly specify that for the scale, I'm going to use scheme equals plasma. So this is saying what color schemes should I use? So I think that's one of the most common types of customizations that people do to their Altair charts is choosing a color scheme. And you can click this link here to see different options. And so let me go quickly through these next things, and we can practice with them during the exercises. Here's just going to be an example of putting some charts side by side. So this is a little function that takes as input a string and as output makes an Altair chart with that string as giving what should be the y-axis encoding. Okay, so this has 3 charts side by side. So for example, if I do chart list bracket 1, then I should get acceleration for the y-axis encoding. And so if I want to concatenate these side by side, I can use the hconcat function from Altair. And this is a little different from pandas. In pandas, you pass to concat a list. Here, we want to pass the individual charts. So I have to unpack the list with this star. So this would be the same as chart list 0, chart list 1, chart list 2, getting passed as 3 arguments. And so this is all the same. These should all have the same number of points in them, but they correspond to different y-axis encodings. Okay, so they all have the same x-axis encoding, all have the same color encoding, but different y-axis encodings. Yes? Do you know if hconcat will take a generator?
I don't know.
Yeah, we're not sure. Okay, and this is another example where some code you'll find on the internet will, to my eyes, look a little less nice. So rather than using the scale method up here, so here I do alt.color, and then I use this scale method, and I say, for the scale, I want to use the color scheme plasma. And so in Altair version 4 and earlier, maybe even 5.1 and earlier, you had to use it as this kind of argument inside the alt.color. So just used to look a little less nice. And so if that were all I wanted to do with this concat, I don't know if I would have even showed it to you, but I wanted to contrast that with faceting. And so to show you that, let's see, let me copy paste this. And so let's see, does this work? Okay, so here I haven't done anything new yet, but for example, let's add a new column. Sorry, the copy paste is a little off. So let's add a new encoding, and I think this is pretty interesting. Let's do alt.column origin. And so here again, we have 3 charts side by side. Let's see, let me zoom out so you can see both the code and the charts. Here we have 3 charts side by side, but up above, each of these had the same number of circles in it. It was like the exact same data presented 3 different ways. Whereas here, these do not have the same number of circles in them. Here it is different subsets of the data. And so what Altair is doing here is it's saying we are going to encode the origin column as the column visual property of the chart. So if the origin is Europe, we're going to put it in the Europe column. Okay, just like how before, if the origin is Europe, we're going to give it the Europe color. It's the same kind of reasoning. Here the origin is Europe, and we put it in the Europe column. And here we put Japan in the Japan column and USA in the USA column. So that's a big difference between concatenation and faceting. So I don't think it would make sense to do concatenation using something like alt.concat here. I don't feel like that would really make sense. So there's sort of different aspects of this. Yeah, and, let me just finish up. I don't think I'll do any of these, but I have some quotes here I like, which are for customizing. For example, we've already seen customizing scales. And so this quote from the Vega-Lite documentation is, scales are functions that transform from data values to visual values. So like, for example, from the data value USA to the color value or the visual value orange, something like that. So that was scale. Axes provide like visual helper cues for these scales. So let me just read the quote directly. Axes provide axis lines, ticks, and labels to convey how a positional range represents a data range. Simply put, axes visualize scales. So for example, if we wanted to get rid of these grid lines, that would be something we'd do with axis, not with scale, because it's like, how are they visualized? So that is axis versus scale. And yeah, this last one, maybe it's worth showing you. Oh. Okay, great. And so I think if you've used definitely Seaborn, I'm not sure about Plotly Express before. I believe Seaborn is a little more forgiving about, like Seaborn can very happily plot something like this, but Altair cannot very happily plot something like this. And the problem is that this is not what's in so-called tidy form. In tidy form data, we want each column to correspond to some variable, and each row corresponds to one observation. Here, this is a little different because these are correlation values between these different columns in this data frame. And it's like in all of the 5 different columns, they sort of correspond to the same variable. They correspond to the correlation variable. So this is not what's in so-called tidy form. And here I'm using pandas to get it in tidy form. So here we get a multi-index, which is something in pandas I've never gotten super comfortable with. And here I'm going to move these. Also, as far as I know, Altair cannot get data from the index. Do you know if that's right, John? That you can't get data from an index? So here we're like moving these out of this index and into their own columns. So like, for example, how about this thing here? We really want to think about that as saying, what is the correlation value corresponding to year versus population? So like, how are year and population correlated in this data frame? And so it's like year is one variable, population is another variable, and this 0.094 is another variable. That's the correlation. And so down here using this stack and reset index, now this, like for us as people, I would say it's harder to read, but for Altair, plotting from this kind of information will be easier. So this was named DFC for data frame correlation. And this is in tidy form. And here is our first example of a rectangle mark for making like a heat map. And so we're saying the x-coordinate corresponds to the first column. The y-coordinate corresponds to the second column or the second predictor. And the colors are going to be based on correlation. And here's one where we choose a diverging color scheme, where it's like between purple and orange. So yeah, I know I was going much faster at the end than I was at the beginning, but we'll have a chance to practice some of these things in the part 1 exercises, which are over here in this same part one directory. And so when should we start on part 2, would you say, John?
Let's start at 9:30, so it's 35 minutes from now to
Okay.
do the exercise and take a break if people want to take a break during that time.
Okay, great. So we'll start with part 2 at 9:30. So that's like 35 minutes to take a little break, work on the exercises, ask John and me for anything we move too quickly through.
You want to outline the exercise?
Oh, sure.
Talk about it a little bit.
And so I chose the Vega-Altair tutorial again. And so I'd say the first one is really about just getting comfortable with the syntax and choosing a color scheme. And this will be our first example of using what's called the temporal data encoding type, which is designed for time encodings. Like in this case, it corresponds to release dates of songs in this data set. And this data set, it's not quite the thing I linked to on Kaggle. I cleaned it up a tiny bit. But that is in this directory here.
Explain the show answer, show image.
Oh, sure. So show image is if you kind of read these instructions and you're unsure, like what is this even asking, you can click on the show image. And that will show one possible image for what the final product might look like. And show answer, if you click on this, it will show one suggested, like the suggested way that either John or I solved the exercise. And yeah, and I think most of these are pretty self-explanatory. Some of them might use things that we didn't talk about, and in that case, either we tried to provide a link to show you how to do that, or it's just a mistake on our part, and you should flag one of us down, and we will explain it better. And a lot of these are based on examples from the Altair example gallery, just sort of helping you build up to that example. Okay, yeah, so work on these or go through part 1 or take a break, and we'll start with part 2 at 9:30. And yeah, John and I are very happy to answer anything from part 1 or from the exercises or anything else. computer works basically exactly the same as mine. Or I might have zoomed out at some point and forgotten to zoom back in. Did you notice if the coffee was still out?
It is still out.
Excellent. you're not giving Altair the data, or it's coming from somewhere else, then you have to explicitly tell it what to use, because it can't infer whether it should be numbers or whether it should be strings. So like if you have a huge data set and you're not explicitly like giving it into your notebook, then you need to explicitly give a colon and a colon string for every one of these coding. Right, yeah. So here may be important is that the encoding type needs to always be specified if you're using like a URL or something.
True, true.
You can think about what you want to say that at the beginning.
You did say that.
Oh, did I say that? In like voice or in writing?
You voiced it.
Oh, okay, excellent. I'm going to check the video later.
You can all say it again.
Yeah, I don't really cover the URL version.
Yeah, I don't remember saying it, but that doesn't necessarily mean anything.
Yeah, we didn't really cover the URL version. I don't think it was really all that useful or practice. So,
Right, like in here, it's not really important.
for Altair.
I guess like it's important because when we do the transforms and things, then you need to explicitly state it.
Yeah, I can mention.
So I guess that'll show up sort of naturally there.
We're gonna start part 2 in about 5 minutes. If you want to take a break, Steve, a chance.
for the tutorials.
Okay.
Yeah, definitely that long.
Because I'd like to do the Barley exercise, but we're not going to have time for me to do that, so I want to be able to do it later.
Sure, and I should point out all these notebooks are on GitHub, but you
Oh.
want to use set up yourself.
Oh, okay.
So if you don't get to it through Jabari, I'll mention that.
Cool. So then I can just do it locally. Sweet.
Yeah, yeah,
Okay.
yeah.
Awesome.
Let's start with that.
Yeah, all Nabari is doing is going to our GitHub repository and updating the things from that.
Oh, okay, sweet. Yeah.
Yeah. All right, go ahead and get started towards part 2, but wanted to just point out from a good question, all of these notebooks that we're going through are available on GitHub. They're inside the Vega GitHub organization under SciPy's 2024 Altair tutorial. So I'm not sure how long the Nabari sessions are going to be around, but if you want to keep working through things locally, these resources are all available here. We do have instructions for setting up the environment necessary manually if you just want to use it in a normal local Conda environment or virtual environment. It's pretty straightforward. There's just the Altair package with the set of extras enabled. So that's what you can. However, whenever Nabari disappears, you can switch to using these notebooks directly from this GitHub repository.
Can you just make it a little bit bigger to see the name of the repo?
Yes, sure.
Oh, just for bigger.
Yeah, it's in the main Vega GitHub org that you can search for.
Cool. Thanks.
Yeah, sure. Sure. All right, we're going to move on to part 2. So open up the part 2 directory and the data transformations notebook here. Going to hide that. Okay. So for part 2, we're going to talk about how Altair has built-in support for transforming data as part of the visualization pipeline. A very important, probably the most important form of transformation that Altair supports is its support for binning and aggregation. And we'll also touch on, if we have time, some more advanced forms of transformation that you can do for things like filtering and calculating new columns. So until now, all the charts that we've created and that you've created in the exercises have mapped individual columns of the input data directly to individual mark instances in the output. So a row of input data will get mapped to a single circle in the output or a single bar. What transformation lets us do is make that more flexible. So for example, with aggregation, we can map a collection of rows to a single output mark, like a bar and histogram, using some sort of aggregation function, like counting the number of rows in that group. There's a lot here we're not going to cover, so if you're just curious, you can look at the Altair has a section on data transformations in the documentation that cover a wide range of transformations that we're not going to cover them all here, but we'll touch on the ones that I think are most commonly useful for exploratory workflows. This section is heavily based on some visualization curriculum that was developed at the University of Washington. It's available, it was originally developed for Altair 4, so we did a lot of updating to match the new syntax and conventions, but the pedagogical structure was very, very helpful, and we talked to them and worked through updating it for Altair 5. So let's get started with our normal imports. This section is going to be based on the movies data set that comes with the Vega datasets package. So again, this data import came from the Vega datasets Python package. This movies data set has about 3,200 rows in it, one for each of this collection of movies that were scraped from various sources. This data set is really nice for visualization work because it has lots of little errors in it, it has lots of missing values, so it's very realistic in terms of the kind of things you run into with working with real data. it shouldn't be considered like comprehensive or actually representative of a particular distribution of movies, but it's very helpful for this kind of investigation and learning how to do the different chart methods we're going to do. So let's load it up. 3,201 rows, 16 columns. So here's the kind of things that are contained in it. We got the title of each movie, some information about the gross for domestic United States and worldwide, budget, release date, ratings, Rotten Tomatoes and IMDb ratings, and things like that. So it's a lot of nice variation in the columns that are available. That'll be a good way for us to explore these different transformation approaches. So the most important, in my opinion, transformation for visualization is the binning and aggregation process that is used to build up what are called histogram charts. In other plotting libraries, you'll often have like a histogram function to build a histogram chart from in one shot. And in Altair, this process is broken up into a few pieces that are independent but can be used together to create a histogram, and also much more flexible other kinds of charts with binning as well. So to get started, I'm going to look at a scatter plot of the Rotten Tomatoes rating versus IMDb rating. So here, this is just like a chart we've done in the past section, no transformations yet. Each circle here represents one movie, one row in that data set. And again, the mark type is circle. And as the next step, we're going to look at, basically we're going to work through turning this into a histogram one step at a time, and work through understanding each of these components individually. So to summarize this data set, the first thing we want to do is bin the X values. So we want to group together movies that have similar Rotten Tomatoes ratings into discrete chunks that will eventually be our bars or histogram. And the way we do that in Altair is by adding this bin method call to the encoding that we want to bin. So I'm not going to aggregate anything yet. This is just applying the binning portion of the process. And so now we still have one circle for every row in the data set, but now the X values have been truncated or binned into these discrete intervals. Discrete intervals have been truncated into common values. By default, bin will choose nice around 10 bins with nice edges for where they fall in the bins. You can customize the number of bins with this max bins property. One thing just I want to mention is that max bins is like the upper bound on the number of bins. It's sort of a suggestion for the number of bins to use as, and then Vega underneath Altair will use that to choose basically human-friendly bin edges for everything, so that your edges will fall on nice values like 5 and 10 and 20, and not on just the kind of naive approach of taking the min-max and dividing it by 10, which often gives you very messy bin results. So that's part of the advantage of doing this through Altair, is that you get this nice binning edge calculation. So we're going to stick with max bins of 20. And then we're going to look at turning this into applying an aggregation. So here in this next chunk, the X encoding is the same. We're using the Rotten Tomatoes rating and binning it. But for Y, instead of using the IMDb rating as we did previously, we're going to use this count syntax. So count here is not a column. This is an aggregation function. And in addition to count, there are other aggregations like mean, min, max, standard deviation, and several others. And what this tells Altair to do is, for each unique value of all of the other encodings, in this case for each unique value of X that shows up, compute Y by counting the number of rows that fall into that unique value. So here,
For those aggregation functions that John mentioned, I think count is the unique one that does not take any argument in the parentheses. For something like mean, then you put a column name into the parentheses, and it decides the value based on what is the average for that column.
Yep.
The count, it doesn't need a column name.
Yep. So Chris was saying that for the count aggregation, you don't need a column name as part of this. There aren't any arguments to this function call, but for the other aggregation functions, we'll end up putting column names inside these parentheses. So this is almost a histogram, but we're still using circles. So to make this look more like a traditional histogram, we can switch the the mark type from circle to bar, and then we have a histogram. And here you can see more easily that the bin edges have been chosen to land on nice boundaries. So it looks like 0, 5, 10, 15, 20 as the boundaries. And you can see that in this case, the Rotten Tomatoes rating is fairly uniform. I think there's a slight skew towards higher ratings, but it's a pretty flat distribution. And there are some notes here in this observation section about how Rotten Tomatoes and IMDb rating relate to each other. But here we're going to take the same chart as above, but look at the IMDb rating, which is a 1 to 10 rating. And notice its distribution is very nicely bell-shaped with a little bit of skew. And there are some thoughts here on like why these two rating systems end up working differently. I won't dig into right now for the sake of time. So that's a histogram. And you might wonder like why build it up this way? Why have these two parts be separate things rather than just have a histogram method? And one of the reasons is that these primitives of binning and aggregation can be used in a lot more places than just in histogram. So in this example, let's try binning both the x and y values. When I do this, I'm taking an initial scatter plot and binning both the x and y. Because I haven't aggregated anything, these plots, these points are overlaying on top of each other. So you can see that there's a lot of overplotting. The lighter ones represent only a few points overlapping. Darker ones represent many overlapping. This is based on the opacity. But now we have the opportunity to add in an aggregation function for another encoding in our visualization. So one choice for this is to use size. So now we can, for the size encoding, rather than give it a column, we can use this aggregation function count as the size. And Altair will take care of determining a reasonable range of count values. We don't have to specify like the min, the max of these counts, which saves a lot of time. And this is essentially a histogram, but now it's in 2 dimensions, and we use size as the circle size as the representation of the count. By just changing the mark type from circle to rectangle, everything else here is the same. We can get a heat map of the same values, where now the data points have been binned into these rating bins, and we use the color now to show the count in that bin. Something interesting is like these two charts show the exact same information, this circle based on size and this heat map. And there are trade-offs in terms of which ones you want to use. One thing to think about is that for comparing individual, like pairwise values, like if I imagine I'm comparing the values in this row, looking at the circles makes it pretty easy to tell visually that these, the relative sizes, compare the relative sizes of these circles. But it's not as easy to see the overall distribution. And in contrast, the heat map, generally, if you sort of squint at it, you can see this overall distribution of values pretty easily, but it's much harder to look at two like squares across a little bit of range and identify whether they have the same or which one's a little larger, which one's a little smaller in count. So depending on what you're trying to communicate, those are things to consider in how you're building up this chart.
Related to what you were just saying about the circles,
Mhm.
how is their size actually being scaled? Is that based off of the diameter, the radius, the area,
That's a good question. So the question is, how is the size of the circles here being encoded? And it is based on area. It's an area encoding. Yep.
Interesting.
Yep.
In the heat map, there's lots of bins that don't have any data because there's no count there. But it looks like they're just not plotted rather than they're using like the value of 0
Yeah, so the observation, I guess, is that for this heat map, we have a lot of empty area where no data values were present in the data set, and so we end up with the sort of empty value rather than the color map's 0 value. And this is a consequence of how Altair treats this data as being tidy. So there is no, like this heat map is basically a scatter plot where each rectangle corresponds to a row of the aggregated data frame. And so just in the same way that for a scatter plot, you don't show data where there isn't any. In this case, like when there isn't any data in these bin values, there's nothing to show, and so it does is represented as being missing rather than nothing. It would take, I'm sure there's a way to do it, but it would take some more work to actually, if you wanted to fill in zeros for all those other values. You could do that too, yeah. And then for other aggregations like mean, you wouldn't really want to do that because then you would be sort of introducing data that isn't there. But yeah, that is what's happening.
The only problem with doing background color is I don't know if there'd be any way to calculate the background color from the scale. So I think you might have to say I want the background color to be orange or something. I don't know if there'd be to say I want the background color to be what corresponds to 0.
Yeah. So to look at a few more aggregations. Here's an example where we're going to look at the average of the Rotten Tomatoes rating for each genre. So genre is a string value. It's already nominal, so it doesn't need to be binned. We can already group by it because it's a string, so that is why we don't need to do the .bin on this encoding. And we can directly apply an aggregation. So here we're using the average, and as Chris mentioned earlier, for the average aggregation, we need to pass in essentially the column that we want to take the average of, and that will generate, there we go, this chart. So here we have this average Rotten Tomatoes rating on the x-axis and the genre on the y. The order here, by default, is alphabetical based on the name of the genre, which, apart from anything else, is a reasonable default. But in this case, that's not the most helpful way to look at this information. And so in the presence of these aggregations, we can also add sorting. So here, we can sort the y values by, and this syntax means we want to sort them by their x position in descending order. So the minus is for descending, x is for the x encoding, and now we get this nicer to look at sorted histograms. So we can see really easily that documentary and musical genre movies tend to get better reviews. Romantic comedy and horror movies get worse reviews, and we have this null value floating around that we have to do some research to figure out what that corresponds to. But that is present in our data, and those get favorable reviews as well. In addition to using an aggregation to compute like a single value to summarize, we can also use multiple aggregations to show ranges of things. Before I look at that, this is an update of the same chart using a median. You can now see the median is a more robust statistic than a mean. A median is looking at the very middle value of a sorted, of the sorted set of values for that dimension, and so it's not influenced by extreme values as nearly as to the degree that a mean is. When we compare them, we can see that the order of these shifted around a little bit. Null bumped up to the top when we look at the median, but overall, very similar distribution of values here. There are a couple other aggregation functions that are useful for showing statistical ranges. Q1 and Q3 are sort of complements to median. Q1 is the first quartile, so the value at which a quarter of values are less than the quartile, and Q3 is the third quartile. And if we look at the range between them, we get a better sense of the distribution of values. So here, I'm taking the X encoding of the bar to be Q1. A bar has an optional X2 encoding, so that way we can set the start and end position of the bar, and so I'm saying that has to be the Q3 aggregation. So this is an example of using multiple aggregations in the same chart for different encoding channels. And then for Y, I can choose how to sort them. So let me just run this without anything, without the sort portion. So here we'll get, for each row, the first quartile and third quartile, and then the sorting, again, is back to being alphabetical because we didn't specify anything in particular. To sort here, we don't want to sort by just one of the edges. Or we could, but rather than sort by just the start or end edge, we want to sort here by the median of the distribution, which will fall somewhere inside this bar. And so this is a more general form of sorting that lets you choose the operation to sort by. So I'm going to sort by the median of the Rotten Tomatoes rating in descending order. So here, now each bar, we don't have the median shown yet. We'll do that in the next step. But now each bar is sorted by its median, and we can see the range of the statistical range of values. Now I'm going to do an overlay. So here's the same base chart we had above with the X and X2 based on Q1 and Q3 aggregations. And now use this syntax to overlay another mark on top. So this plus operator lets us take two different charts, overlay them on top of each other, and they'll share the same X and Y scales. So in this case, I'm just going to say I want the X to be the median of the Rotten Tomatoes rating, and that will give us a little red tick at the median of each bar, and now we can see how the sorting matches the median.
Yes, that's sort of like concatenation, but instead of having them side by side, they're like right on top of each other. This layering.
Yeah, yeah.
So we can see here the x-axis label is becoming a little unstable.
Yes.
At some point, a possibility to override that with a custom label or something?
Yes, yeah. Let me try this on the fly.
We're going to talk about later. That's a different one.
I think. Oh, and do that right. I'll come around to that during exercise time.
Yep, no worries.
Yeah. Blanking on the right way to do that on an overlay. Okay, and so looking at another form of binning for time columns is it's often useful to bin based on a time unit. So in this case, we're going to look at the US gross of the different movies, but bin them by the month of their release. So here also showing another mark type. So if I went back to bar, it would look like this. And area is just another mark type we can use to look at the range over time. But you can see an interesting, just seasonal distribution of the median US gross of the movies based on the month they're released. And this is wrapping, kind of like wrapping around all of, like these movies are released across many years, and this is binning them into a common set of months, basically wrapping around the data, so all the movies released in January across all years are grouped together. And we can look at the same thing for median and see a very similar distribution between the mean and median cases.
You know, is mark area the same as mark line, and then it just fills in underneath it?
Yes, except area does different stacking behavior when you have multiple of them. But yeah, it's very similar to line. In this case, we could use a line as well, and that would have the same behavior. So I want to take a step back and talk a little bit about the. Oh, sorry, yeah.
Would you subtract the US earnings from the worldwide?
Yes, there's an example below. We'll do that in a calculated column.
Yeah, we'll do that in the same part. One more question.
Oh yeah.
So you've been writing these little expressions in strings, but then in the sort you use like an op and variable. You separated them instead of like having a string for the expression. Are those interchangeable, or in both the x and y and sort, or do you sometimes have to do the expression as a string, and sometimes you break it out like this?
So this is like the general form where you specify the operation field and order. When the ordering is just based on one of the encoding channels, this is like the shortcut. So we couldn't use the shortcut below because we weren't sorting by just like the x or x2. We were sorting by another aggregation.
Say median open parameter.
Not here.
You can in the other, in the x.
Yeah, not in sort. That would be interesting thing to think about how we would do that. But yeah.
Is there a more verbose version of the like median parentheses Rotten Tomatoes where it's like Rotten Tomatoes then comma all
No.
equals median?
No, there's not. Yeah, the aggregation and the sort strings are different concepts.
Yeah, so if you wanted to do something more complicated where maybe like the analog of the word median doesn't exist, then you would probably have to either A, do it in pandas, of course that's always an option, or B, do it in a transform calculate that I think John will talk about.
So I'll take a quick moment to talk about sort of what's happening in this data transformation architecture. So I'll go back to this histogram. So under the hood, what Altair is doing is it's building a JSON blob in Vega-Altair's format that by default includes the input data. So I can show you this by using this drop-down menu and opening this chart in the Vega editor. If I click on that, this will open this Vega editor page. We get the same chart here. This is the Vega-Lite specification. We're not going to talk about the details, but generally this maps pretty closely to Altair. You got encodings, aggregations, types. What we can see here is that the whole input data set with all the columns, all the rows, is embedded in this specification. And then the transformations are applied by the Vega JavaScript library on the fly as it's rendered. So this works well most of the time, but you can see that this would get unwieldy as this data set gets larger. The chart specifications end up getting very large, that makes your notebook large, it makes it harder to share them, and they get slower in the browser. So what we can do as of Altair 5 is use this new Vega Fusion library. And what this will do when we enable the Vega Fusion data transformer, like this, is that the data transformations, like the data aggregation, are actually run now in the Python kernel before that specification is generated. So now when I open it up in the Vega editor, the data that is inlined is just one row for each bin and the count, the bin start edge, end edge, and the count. So when the data is aggregated now, you're not limited basically based on the size of what can be crammed into the JSON blob because the aggregations can happen on the server. So that's a new thing, and this is also the recommended way to work to address Altair's limit of 5,000 rows. So in this case, this data set is only 3,000 rows, and so Altair doesn't complain about it by default. But if it was over 5,000 rows, we would get an error, and the exercises, you'll see the error, and follow the instructions to how to address it by turning on the Vega Fusion data transformer. Another cool thing that we can do by leveraging what Vega Fusion does is we can look at the transform data directly in Python and see what see the results of this transformation process. So here, I'm taking this chart, the same histogram chart, looking at its transform data with its transform data method, and I see these same bin edges and count values. And this is a nice way to debug more complicated transforms as you build them up. You can look at the intermediary values and see what they're doing. So we have a section next on more advanced transforms. I want to get to the exercises pretty soon, but let me stop here for a minute to see if there are questions we want to talk about first. Yes?
Sorry to already cover this, but why would I do all these data transformations in Altair instead of doing them in like pandas and then just use Altair as like the view layer, so to speak?
Yeah, that's a really good question. The question is, why would you bother doing data transformations in Altair when you can just do them in pandas or polars or something else, and then use Altair to display them? Part of it is for exploratory visualization. It means you don't have to like edit your chart in multiple places. If you are doing transformations to build a new column, for instance, and then plot that column, having that integrated in one place means less places to edit that chart specification. The binning, and I think a really powerful feature is the binning and aggregation being integrated into the chart specification and having the nice bin edges calculated automatically as you're building. That part in particular, I think having it in the chart specification makes things faster to iterate on, as opposed to like binning in pandas or NumPy. Another part is the transformation, the binning transformation. Altair uses that to compute like the bar widths as part of that process, whereas if you do the binning outside, the charting library doesn't know about like what the bin edges should be. It just knows about like the discretized value, and it has to kind of guess how wide the bar should be. That's another piece that happens in line. And then finally, having the transformations happen in Altair means that they can be part of the interactive charts. We'll talk about interactivity in the next section, but if you want your transformations to rerun in response to selections or clicking on stuff, having that happen inside the chart specification means it's all in one place. So it doesn't have to go back to Python to go through pandas or polars or something again in order to do like filtering based on a click, that kind of thing. So those are the main reasons.
Yeah, personally, I find if I'm doing something like pretty immediate, like mean or median, I almost always do it in Altair. And if I'm doing something more complicated, then I usually do it in pandas. It's just personally what I tend to do.
Yeah. All right, so the next class of transformations we look at are not, so the transformations we talked about so far are specified inside the encoding channels. So like adding binning, adding aggregation is done at the encoding channel level as part of building the chart. Other transformation approach is to specify the transformation at the top level of the chart, and this has the effect of basically being more like what you would do in like an external library like pandas, where the transformation happens before the encoding process. So here's the example of, we can use transform calculate to add a new column to the data set that that's calculated before the encoding process. So here is the non-US gross example. We can subtract worldwide gross from US gross and have that as a separate column and then display it. This syntax of these expressions is based on the Vega expression language. So there's a link here. This is a pretty rich expression language. It has a lot of functions, features. It's a very small subset of JavaScript. It's not JavaScript, it's a separate language, but it's a very small subset. The syntax is very similar to a subset of JavaScript. You access columns using this datum syntax to say I want to access the datum worldwide gross column by indexing into datum. And then this column you've added, you can use inside the encodings. So here I'm going to take the median of this non-US gross column. One caveat of this process is that when you calculate a column using transform calculate, Altair doesn't know about the type of it up front because that calculation isn't done in Python. So you have to use the colon encoding, the colon syntax to basically specify the data type for the result. So here we're saying this cube applies to the US gross column. That is then we take the median of it.
Could you show the error message you get if you don't have the colon Q?
See what it says. Unable to determine data type for the field median non-US gross. Verify that the field name is not misspelled. If you're referencing a field from a transform, confirm that the data type is specified correctly. So that's what's happening here.
That's probably the Altair error message I get most often, is it telling me to specify the data type with that colon T or colon Q notation, colon N.
Similar transform is filter. This also accepts a expression that's in this Vega expression language, but it has the effect of filtering the input data before encoding. So here we can filter the measure genre to be romantic comedy before we go through this encoding process.
There was a part 1 exercise about songs or something between 1970 and 1980. Yeah, I think it was songs. And so this would be a way to do that inside of Altair, would be using this transform filter.
Yeah, and in particular for dates, you can use this year function is out of the Vega expression library that'll extract the year from a date-time column, and you can use that to do like calculations based on the year. So here's an example of looking at movies released before 1970 by filtering here.
So would you do filtering by year rather than changing the axis to narrow down the range of years that are displayed?
That would also be a good option, like changing the axis it's sort of ironic, the word we'd use in Altair is domain rather than range, but changing the domain to 1970 to 1980, I think that would actually probably be better now that I think of it, or at least easier, I would say.
Yeah, they're both valid. Either filtering the domain or customizing the domain or filtering to that domain at the filter transform.
I think for specifying on the axis or scale, I would not know how to do like less than 1970. I would only know how to do from 1960 to 1970, because I'm used to specifying 2 endpoints. I'm not sure if there's a good way to just say, give me everything before 1970 on the scale side.
All right, for time, I think I'm going to stop here. There's 2 more examples that I think are interesting below, and in particular, the window transform is very powerful, but it does take some working through to understand it. So if you have time during exercises, you are also welcome to work through this window example. It's pretty well documented. We use the transform data function to look at each step along the way, but the end result is to build up this chart where we show the top 20 directors in the data set ordered by their total gross across all their movies. And using the window transform to basically filter down to that top 20. So let's see if I'm missing anything else we need to. Okay, I think I'm gonna stop there, and I'll introduce the exercise section, and then we can talk about any other questions folks have. So for exercises, whoops, kernel, Altair. For the part 2 exercises, we start with this diamonds example. This diamonds data set is interesting because it has like 50,000 rows in it. So as you follow through this, you'll see the error that Altair raises when you have more than 5,000 rows. And that error explains that you can turn on the Vega Fusion data transformer to work around it, and then the transformations will happen in the kernel. And Vega Fusion also does some things like remove columns that aren't used in that output data set. So even for the cases when you're not aggregating, it reduces the data set size by removing, pruning out unused columns. So we have the same process where there's a description of what to do. If you get a little stuck, you can show the image of the chart that you're going for. And then if you want to, like the answer of what we're looking for, you can expand the show answer case. We'll keep walking around. Let's see. Let's do another half hour. Oh, go ahead.
My impression was these exercises were maybe a little shorter than the part 1 ones, so I think half hour is good.
Okay. So let's plan to start part 3 at 10:40. It's like as a half hour to work through the exercises and take a break if you need one. And Chris and I will be here. I'm going to work through the axis label question next thing. So.
Yes. Yeah, I wasn't sure, like, it is just changing the title of the axis. Is that enough to be helpful? So it doesn't show the Q1 and that kind of stuff?
In the afternoon of the day. It's like it's, I forget if you can do it before though, but like.
Is doing this just on Jupyter Lab, okay? Yeah.
go to the Vega-Altair and say, okay, I want to know, okay, show you an example. This is what, I just go to the browser and go like, Altair example cover. This makes the overkill right there.
in general, it's come on after 3 seconds. Yeah. Okay, let's go ahead and start up on part 3 on interactivity. And yeah, interactivity is sort of interesting. I think it is simultaneously like one of the most exciting features of Altair, and it's also one of the features that I like personally use myself the least often. So I find that kind of interesting. It's like one of the first things I use as a sales pitch for Altair, but I don't use the interactive portions as much as I might have expected to from how much I was interested in it when I first met interactivity. I use tooltips a lot, so if you count that, I use interactivity a lot, but some of this more advanced interactivity I find myself not using so often. Like I used to teach interactivity in one of my data science classes, and then I just found it was so hard to like write questions about using interactivity that you would answer with pencil and paper that I sort of moved that out of my classes. Okay, let's start on this part 3 on interactivity. So we're going to use that same cars data set again that we were using in part 1. And I'm going to start with 3 examples of interactivity. So you're not meant to really understand the code for these first 3. It's just to show some of the options of what's available in terms of interactivity. And I mentioned earlier that I was switching from the positional argument format to the keyword argument format for tooltip because of later. And the reason for that was here. Here, it does not seem to be possible to have an alt.tooltip on the outside and also on the inside. So this, I don't think it's too obvious, but does anyone see what we're doing with this inside tooltip? Exactly, making a custom title. So let's see that. And so by default, this tooltip would show up with the underscores around per. And so with our custom tooltip, we see there aren't those underscores there. So it's just a minor thing, but showing you what's possible. And so that is tooltip like we've been seeing so far. And then there's one other extra thing that's been added here. I guess there's this size equals 60 up in the mark circle, but then there's also this dot interactive. And what this does is it enables us to pan around in the image, or in the chart, and it allows us to zoom in and out. So I do that by clicking here on the chart, and then doing the same way I would scroll up or scroll down. So like here I'm scrolling up, I think. Here I'm scrolling down, and that helps us zoom in and out. Yeah, I believe it's just as far as I know, what it is doing is it's saying how would we make this chart look if these were the like domains that we specified for the x and y axis. Yes.
Maybe that would make a difference when it was geoscience data, or like if you had polygons and you were zooming in, then it would really give you a better data fidelity. So do you know
Yes.
by chance if there is any geoscientific data visualization support in Altair, for example, maybe polygons or rasterization?
Yes, so there is a fifth data encoding type called GeoJSON, and I think that even shows up in the part 3 exercises with some state maps. And I don't know off the top of my head if you zoom in how that zooming looks, but that would be a fun thing to try when that shows up in the part 3 exercises. Yeah, a question was about geographic capabilities. Okay, so yes, that tooltip we'd already talked about a little bit, and then the other main thing was adding this dot interactive. That was what gave us the panning and zooming functionality, this dot interactive. And you could also get that by hand, but this is a nice automatic way to get that functionality. Okay, so that was example 1. Okay, example 2. This is going to use a transform filter like what John showed in part 2. And yeah, don't try to understand the code, just look at the final result. And so here we have these radio buttons at the bottom. And if I click on USA, then it filters out everything except for the USA. So it keeps the ones that are in USA and filters out everything else. And similarly for Japan and similarly for Europe. So that is another example of interactivity. And then the one that I think is most impressive is here we're going to have a multi-view chart, which means we have several charts based on the same data, and we'll be able to select in one, and that will influence what shows up in the other one. So let's see that. And again, this is one where we're just sort of showing what the possibilities are before we go through more step-by-step how to build these up. And this vertical line, this is like the hconcat from before. This is just a shortcut for hconcat, alt.hconcat. Okay, so here's a concatenated chart. But if I click and drag here on the left, then it selects the corresponding points on the right. And so this is definitely concatenation, not faceting, because remember in faceting there isn't any overlap of the points between the two. But here, this point, this orange point here corresponds to one of these orange points over here. And I can click on the highlighted region, and you see that it updates automatically. And another nice thing, I mentioned this in part 1, but this is all happening on the JavaScript side. So once you find a way to open this up in a website, there doesn't need to be a Python kernel running in the background. This same interactivity will work just with JavaScript. And John, what I said a minute ago was, I think this is like a great sales pitch for Vega-Altair, but I don't find myself using it very often. Do you find yourself using this? Yeah, you do. Yeah. So John does use this kind of functionality. I think it's very cool, but I don't use it myself in data exploration very often. Okay, so any questions before we go more systematically through how to build up these kind of charts? Yes.
Like with that left right that you have, is there a way to get what you filtered? Like, so if you select something in the horsepower, right? Like, can we get that in some way, kind of like the way we did at the other one, where we did transform chart whatever to get the actual thing?
Yes. So this did not used to exist, but thanks to John, this exists. Is this still the transformed data?
At the end of the section.
Okay. You could have just said no, and I would have still been happy. The fact that you said yes is really amazing.
Yes. Okay.
Yeah, but it's one of the newest aspects of Altair. Yeah. Okay, so this tooltip, I don't think I'll say anything about that. We already mentioned briefly about changing the way it's displayed without the underscores. And this pan and zoom, I think we already sort of went through that. So let's go to selection parameters. And so what this is going to do is this is going to provide some framework where we tell Altair what, remember that each point, assuming there's no aggregation, each point corresponds to some row in the original data frame. And so these selection parameters are going to give us a way to say which rows do we want to keep. So, or which rows do we want to select is probably a better way to say it. And so in the background of these selections is what's called a predicate, which is a word we also use in some of my math classes, where a predicate is something like that evaluates to either true or false. So for example, origin would not be a predicate, but origin equals Japan would be a predicate, because that's either true or false. And so in the background for all of these selections is going to be some predicate that decides, is that corresponding row in the data frame, is that selected or not? And we can use these selections in two related but different ways. One is in a transform filter to say, keep the points corresponding to selected rows, discard the points that were not, where the row was not selected. So keep the true, discard the false. Okay, that is the filter option. And then the condition option is going to be something like color the selected rows in red and color the non-selected rows in another way. That's the condition. So I'm going to talk about point selections, and John is going to talk about interval selections in a minute. So here is an example. And so this is like a subset of what we were looking at up above. And so what we do here is we define an Altair selection object. This one is a selection point. When John is talking, it will be selection underscore interval. And how you should read this is it's saying for the different fields, which fields are like the column names in the data frame. So for the column named origin, we want the value to be Japan. So the predicate in this case would be like datum.origin equals Japan. So true for all of the rows where the origin is Japan. And then here we are filtering based on that selection. And so there's not really interactivity at this point, I would say. And so there's sort of three pieces here. We define this selection Python variable to be this Altair selection object. We tell the Altair chart that it should filter using that. And like just as an example, if I were to remove this and run it, I get this not super helpful error that says unrecognized signal name, and that is because I did not add the selection to the chart. And so, yeah, you might think, why doesn't it just automatically add them? You could imagine maybe over the course of your notebook you have 20 of these and you don't want all of them to get automatically added. And so once I added this .add params and then passed it the name of my selection object, now it worked. And now up here we said we want the origin to correspond to Japan. And so it has filtered out all of the ones where the origin is not equal to Japan. Yes? Yes, John and I had intended to keep that a secret, but there's a little more interactivity than we let on at this point. So by adding this selection parameter, you can select by clicking on a point. And so here, if I were to click on a point corresponding to Europe, then it's going to filter the ones where the new predicate, which is origin equals Europe, based on that clicking, it filters out all the other ones. Yes?
Is there an easy way to specify that the domain doesn't change or the range doesn't change? Not
Oh, yeah, I do not know of a smart way to do that. So I was hoping I was going to be able to answer that. And I see this was sort of written in the old-fashioned way where we have this x equals. And so what I was picturing doing was alt.capital X and then saying .scale domain. And then I was planning to just look at these numbers and say I want 0 to 140.
You could use opacity if you want to get that effect.
Oh, okay. Yes. Yeah, I think we'll see that in a second. So maybe I won't try to type it out right now. But so there, like, the reason adding opacity works. So the original question was, what if we want to keep these domain values the same? Because you see, here it goes to 240, whereas when I click here, it switches back to 140. One option would be to hard code it using domain, sort of like the analog of what's written here. And then the workaround that John suggested was add an opacity so that we make all of the other points invisible by giving them an opacity of 0. And so then they're still there in the background, and so Altair would keep the same domain for them. And I think we'll see an example of that in a minute. Yes?
The legend, it looks like it always has all three.
Yes, and that is thanks to this specifying this dot scale. So like, let me show you what happens if I remove it. And not only do they go away, but also the colors will change, which is one of the reasons it's nice to have this. So here's all three of them. Europe is in blue, but like, let's see what happens when I click on Japan. Okay, now Japan is in blue because it's saying, oh, there's only one thing. When there's only one nominal thing, we do it in blue. Yeah, does that answer your question? Yeah. So yeah, the whole point of this sort of random looking .scale domain equals is so that it doesn't bounce around like that based on the selection. Yeah.
Is there a way to enable that where because right now when you first plot the plot, it's already filtered to Japan because that's what you put in the predicate?
Yes.
If you had dropped the value, would it plot all of the points and then enable the interactivity?
Yes, it would not fix the like domain changing thing, but it would still work. So
So that's, yeah, so but now if you click on the blue one, you get Europe alone.
exactly.
Cool.
Yep.
Oh yeah, that's cool, yeah.
Okay. Awesome. Yes.
There's
Yeah.
not a way to have like the legend drop the ones that aren't there, but keep the same color. Like the
Yeah.
it's always blue whether Europe and the US are showing.
Well, I guess so. So there is this. No, I don't think I know how to do that. Like there is also a range, which this was supposed to be in part 1, so I'll just sneak it in here. Like let's make salmon blue. So here I'm specifying that I want Europe to be in the salmon color. I think any HTML recognized color works here. Japan in blue, USA in green. But I think everything is going to go to salmon when I, no, the thing that does not work of what you asked for is that the non-present ones do not disappear now. Yeah. John, I don't think John knows a way to get that functionality either.
To disappear, how would you then know that that data is still in the chart? They disappear.
I mean, I guess it depends on whether you think it's a different chart.
Yeah.
Fair enough.
Yeah, I can see a place for this, but I cannot see a way to achieve it. Yeah, of having like the colors stay the same as we see here, but have the legend only show the one that's present. Yeah, I don't see how to do that. Okay, let's go back here. So here we no longer have a transform filter. Now what we have is this alt.condition, and how you should read this is saying, here is the selection object, and so remember that corresponds to some predicate that's either true or false. And so this is saying for the selected ones, we're going to color based on the origin, and for the non-selected ones, we're going to color based on this HTML color, light gray. And yeah, a common issue people have is they want to, for example, have another column down here, but you can only have column for one of these things. And part of the reason is it's hard to have a good legend in that case, that you have two different columns. Okay, so here we're back to having value. And so when the predicate is true, which in this case says the value is Japan, then it is colored according to the origin. When it is not selected, it is colored as light gray. So if I click one of these other ones, that was a USA car, and so all the USA cars are in red, and the non-selected ones, the Japan and Europe ones, are in light gray. So no transform filter here. And what John had said earlier was you could do something very similar to this with opacity. Yeah, so for example, if I do this opacity equals alt dot condition, and alt.value corresponds to a visual value. Alt.datum corresponds to a data value, like 40 miles per gallon. So in this case, I want my opacity to be a visual value, like opacity 1 or opacity 0. So I'm going to use alt.value 1, alt.value 0. And what I'm hoping happens here is that even if I switch to Europe and those cars are all clustered over here on the left, the domain should stay exactly the same, even though we never typed in like a hard-coded 240.
With that hack, I would expect actually the USA, the red circle, to also become transparent and disappear. That would maybe be what was being asked here.
Oh, I don't think I understood.
So when you're making the opacity or the color of the point change,
Yes.
I would actually expect that the label and that would also change to match, so that right now, USA, the little circle would disappear because its opacity is 0. Or the color, I think before when you were using light gray, I didn't see the legend colors change. So you made Europe light gray, but it didn't change in the legend. I would have probably expected that, even though I wouldn't expect them to poof entirely from the legend, because the data is in the graph.
I see. Yeah, so the question, just for the recording, was how come when I click here, the opacity of these non-selected ones, like Europe and Japan in this case, how come the opacity of these in the legend does not go to 0? And yeah, I feel like this is just sort of how it works. I don't think I have anything intelligent to say.
The example later, you can bind the selection to the legend. It does that.
Oh, okay.
That's what that's for.
So it's a different object.
Okay, so and then the colors will change in the legend? Okay, cool.
I threw you off with this ordering of things.
Okay, awesome. Yeah, and so let's see. Let's go to this one. So this is here we create this this drop-down menu, which the Altair name for that is binding select. And let's just see how that works. And so here I have this drop-down menu. I have these 3 different options in the drop-down menu. And you could add something else to that also, I believe, like you could add SciPy. Okay, and now there's going to be a SciPy option. Okay, and there nothing gets selected because nothing has origin corresponding to SciPy. Okay, very exact same example, but with radio buttons. So here it is binding radio instead of binding select. And so same idea, but here there are these different radio buttons. Yeah, I'm going a little fast because I know we want to be sure we get to part 4. Another example here is, I guess we've sort of already talked about this with clicking. So in this case, I'm not passing any arguments to my selection point. So for example, up here we were saying we only care about the origin, and we bound it to that radio button widget. Okay, here we don't have any of that. We just say make a selection point. So when you're working with selections, there's sort of 3 things you need to do. You need to create the selection in Altair. Okay, that's what we're doing up here. You need to add it to the chart. That's what we're doing here in the add params section. And then you need to say, like, how is the chart supposed to change based on that selection? And so we do that 3 different places here. We say the size should change from 300 pixels to 60 pixels. The order should change. I think this is our first time seeing order, but that's like, where does it show up in terms of, like, is it plotted at the front of the chart or the back of the chart? Like, could it be covered by other ones? And so this is saying the selected ones should be at the front. They should not be selected. They should not be covered by other ones. And then the colors, like what we were seeing above. And so if I click on, like, let me try clicking on this blue one, and notice how this blue one is sort of in the background, and we just see a little bit of it. But once I click on it, it should come to the front because of that order encoding. And maybe just as, so there I had to click. Okay, if I move my mouse around, nothing happens. Maybe just to show you one other possibility. Let me copy paste this. And let me add, how about, on equals pointer over. Okay, and now I'm not clicking. It's just sort of automatically following my mouse. And if I say nearest equals true, then it says I don't need to be exactly over one of the points. Just go to the nearest one and select that one. Okay, and so for example, here it is selecting this one because it's nearest to the mouse cursor. And yeah, we've been using this fields notion a bunch, and that is saying our predicate is not, it has to be exactly the same point. It needs to be any row that matches the origin. Okay, so for example, up here, if I change, for example, fields equals origin, I believe it needs to be in a list, even if you're just giving one of them. Okay, so now it is selecting the parameter, the predicate is origin should be Japan or whatever was selected. Okay, so whereas without that, it was selecting all of the entries should be the same, so it should be like the exact same point. So any questions about that? I know it's sort of subtle. It's like, is the predicate the point is the point I selected, or is the predicate the origin should match the origin of the point I selected? And so that was called fields, that thing we've been using. And so fields is supposed to take a list of column names. There's another one called encodings, and that one takes a list of the encoding types, like X or like color. So here we say, I want to select everything that has the same size and the same color. And size corresponds to cylinders. Color corresponds to origin, it looks like. Okay, and so if I click there, like, notice these two both have the same origin, okay, or both have the same color, I should say, but we need it to not only have the same color, but also should have the same size. Okay, and so that's why when I choose one of them, it doesn't also choose the other one. And then here is the legend that was asked about before. And so I guess I will notice for the first time whether the colors in the legend change according to this. So the color is supposed to be either the 3 colors like we're used to or light gray. And remember before when we didn't have the binding, okay, when we didn't have the binding to legend, there the colors always stayed the same in the legend. Oh, I see.
Oh, it's the other way. Oh, okay, okay. So you would need to do this and the other one, and then you have both.
Yeah, would there be a way to also be able to click here on the scatter plot? Or is it not sort of two-directional like that? Okay, yes, so John will do the second part of part 3.
Okay, so as Chris has described, there are 2 selection types, point and interval. So all the point selections we talked about are matching exact values to what you've selected. Intervals are based on a range. So the predicate is something like the column value is between a lower and upper bound. And this is how box selection works, but there are other cases as well. So here, let's look at a very simple interval case. We're going to initialize the interval based on the x and y encodings, and notice how it's used. So here, when you enable an interval selection, when it's added as the add params of the chart, that will tell Altair to configure itself so that the interval selection is driven by that particular chart. And the way it's driven by that chart is with this box that you can drag around. You can also zoom on it with a scroll zoom, as I think Chris mentioned earlier. Let's see. Yes, okay, so that's the interval selection. The value part is not required. You can leave that out, and then the chart will initialize itself as being unselected. But encodings has an interesting effect here. So with encodings, that's, again, saying which column should be part of the predicate. So we're saying here, we only want the X encoding column, horsepower, to be used in the predicate. And the way to make that happen interactively is for Altair to restrict the selection to be basically just horizontal selection. So you can't select by mouse per gallon anymore because that's not part of the predicate we ask it to use. When this is X and Y, which is the default, then you get selection in both. So that's how you can restrict which dimensions or columns are used for the interval selection.
Restrict the size of the box. So when you first run it, by default, the box is whatever you specified there, 50 by 50, and you can drag it around. But then if you draw a different box, you've lost the original one. Is there a way to restrict that size?
Oh.
You're always dragging a 50 by 50, so you don't accidentally lose that?
There are some more options on what events are allowed to be used. Let me look into that during the exercise. I'll come look at it. So far we've only looked at selections where the selection is used on a single chart, a single pane chart. But where this becomes most powerful is in the context of multiple view charts, in particular concatenation. And so here, let me just show this example. Here I'm taking 2 nearly identical scatter charts that use a different Y, use a different X encoding, horsepower versus acceleration, and then concatenate them together. What I've done here is for both cases, the color is conditioned on the selection, with the left and the right, and I've added the selection only to the left chart. What that does is I can select on the left chart, the selection is used both places, but I can't select on the right. And the reason I wanted to do this example is to try to make clear what impact the adding parameter part has on how the selections work. When you see the add parameter part of things, the way you can think about it is this is the subchart that should drive the selection. This is the one that should be configured so that I can click on it, or I can drag it, or I can use this legend to drive the selection. But then you can use that selection in any other chart in your multiple pane chart. So I can use it here as part of the color without adding it, and that gives you this behavior. And then if I want both of them to be selectable, I can just add it to both, and then now both of them are selectable. But in more complicated cases, you may want only one of the panes to be used to drive the selection and have it be displayed other places. Another case that I think is pretty cool for interval selection is you can bind it to the scales of a chart. So rather than draw a box selection, when you bind the interval selection to the scales of a chart, it'll enable the pan and zoom behavior. And the extent of the pan and zoom view becomes the box or the interval selection that gets applied somewhere else. So here I'm defining the selection, I'm adding it to the left chart, not doing anything with the selection in terms of the encodings. I'm not filtering, I'm not using it for any visual encoding. I'm just adding it here. This will turn on the pan and zoom action, and then the selection is used in the right chart to condition the colors. So I can zoom now I can zoom here, and the viewport of points that are available in the left are used to determine whether to color the charts on the right. And this can be used to build like mini-map kind of interactions where you have like an overview and detail kind of view. In this case, like, I can't do any interaction on the right chart because I didn't add the selection there, I only added it here. This idea of like adding the selection turns on pan and zoom. That's what the .interactive call does under the hood. But it's this more powerful concept of being able to use the viewport of your pan and zoom to select data in other charts.
So that's kind of doing the box thing that I wanted, that I was asking about, where like you have a fixed box and you could look around.
You could, yeah, but you can also.
Similar to what I was originally thinking.
Right, but you can also get it in Python, and I'll show you in a minute.
This is really cool.
One last thing I wanted to show here was a case where the selection is applied to a scatter plot, and then I'm using that selection to color the scatter plot based on its selection by origin or gray. And that selection then is used to filter, with transform filter, a bar chart underneath it. So amper is vertical concatenation. So the bar is horizontal concatenation, amper is vertical concatenation. And now when I select here, the bar chart is filtered alongside it. One thing to note here, this transform filter is at the end of the chart, it's after encoding. It doesn't matter where this is, whether this is placed before or after mark bar or encode. Conceptually it comes before because the filtering happens before the chart is displayed, but for ease of syntax, sometimes we put it at the end just to make the code itself more concise, but it doesn't matter what order the transform values go in.
There was the question earlier about why do filtering in Altair rather than in pandas, and so this would be an example of where definitely could not do this just in pandas with the interactivity.
The final thing from this section I want to talk about was the Jupyter widget that we've added to Altair. This is what gives you the ability to access the selected state of a chart in Python. This is built on any widget. I think there's a tutorial on any widget soon. I'm not sure if it's today or tomorrow. But this is built on any widget, which is a great framework for building this kind of thing. The way it works is you wrap a regular Altair chart in this Jupyter chart wrapper, and then this thing, Jupyter chart, when it displays, it's using the Jupyter widget infrastructure that any widget uses, and sets up a bidirectional link between the Python kernel and the chart. So now if I click on a point, all right, this is interval selection. If I select a box of points, I can take this chart selection, this Jupyter chart, get its selections. Brush is the name of the selection I specified up here, and then get the selection value, and this is the information that is in the predicate. So here I have the horsepower, miles per gallon ranges, and as I move this around, these get updated. You can see the little indicator bar there. It doesn't flicker anymore. It used to flicker when I drag it around. But it's running the Python code to update this this selection while you drag. A more complicated example uses this selection to show the selected points in a HTML table using the pandas data frames to HTML method as a simple way to build a table of the selected data. So here, each time I do a selection, the selection is going back into Python and then using pandas to filter it, and then the filtered pandas data is pushed into this HTML table. And this runs live, and so you can use this kind of thing to build up little dashboards in the notebook. This is a regular Jupyter widget, so it works with Voila and Solara as frameworks, also with Panel, which supports Jupyter widgets. So it's a fair number of places you can use it. It works in Colab and VS Code. So it's pretty flexible approach. So let me stop for questions here. I think what I'm going to do is, part 4 is very short. I think I'm going to go right into part 4 and cover how we export charts, and then leave the last half hour for the exercise on part 3. Part 4 with exercise session was pretty open-ended anyway, so I think we can kind of combine those together for the last half hour, if that makes sense.
Sounds good.
Yeah.
Question here, is there an easy way to get that data out as a file or something, selection? Is that another widget you would need to put in?
So if you wanted to export the table that's selected, so what you could do, so here, this chart widget, this is the Jupyter chart, selections observed. This is installing a callback on that brush selection. So this onSelect function is what gets evaluated every time the selection is dragged around. So in here, you could do whatever you want in this function. This function could, you could save the file every time. You probably don't want to save it to every time you drag, but you could have a separate callback on a button or something that would click the button to export. So yeah, that'd be a nice workflow. Any other selection questions before I jump to export? This one? So run this one.
And then can you change the selection? And then, so I got that. Doesn't change.
When you do this, it doesn't change the. So here I have horsepower 62. If I go over here, horsepower 175.
You can also deselect it and it just comes back to the
Yeah, if you deselect, you get nothing. Is yours not changing at all?
No, maybe I was just confused about what to expect. So.
Okay. This is the box extents. It's not the data itself coming back. So there isn't an automatic way to convert these box extents into the selected rows. This example below builds up a pandas filter query to do it. One thing we want to figure out eventually is how to automate that. It's a little subtle how to do that in a general way. for how all Altair selections work. But for now, if you want to filter the data, input data based on the selection, you have to write a little bit of pandas code to do that. All right, let me jump to part 4. Reading this one, Chris? I can't remember.
I think you were doing
Okay,
so.
okay, all right. So this is pretty quick. For sharing and publishing visualizations, when you want to share an Altair chart, you can always just screenshot it, but we have some better ways to handle sharing charts. A couple of considerations to think about when you want to share a chart is whether the person or the system that's going to consume the chart has access to a web browser, or whether it needs to be in a static format, and that influences what direction your saving approach needs to go. So here's a simple chart to use for saving purposes, creating an output directory for us to put the files into. Most of this work is just using the chart.save method, and a lot of stuff is inferred automatically. So the file extension is used to determine what format to use. So saying as HTML is a nice approach if you want to like email a file to somebody and they can open it in a web browser. You can get and this will include the interactivity that you added. By default, the HTML files that are opened here, if I dare do this, load the JavaScript libraries from an online CDN. So by default, this will require an internet connection in order to read the plot. If that's not okay for your workflow, there is an inline option that will instead embed everything inside the chart. This will probably crash something. I'll try it. Oh, there we go. So this, instead of having the CDN URLs, it has all the JavaScript code for all the libraries that Vega uses. Altair's Vega and Vega-Lite use embedded in line. And so that is something you can email and open yourself later without an internet connection. It's much larger. That's why it's not the default. But that's what you need to do when you want to access it offline. Another cool thing you can do is use the Vega editor that we showed briefly. When you do this drop-down menu on a chart, there's this open in Vega editor drop-down entry, and so you can click that. You can go through this process of sharing the chart from the editor, where you can basically get this link that if you paste the link into the browser, it's a long link, but it has the whole chart encoded in the URL.
Sometimes it's very long, like 20,000 characters,
Yeah,
I think.
this is only workable for small data sets. But the nice thing there is you're just basically sending this URL to somebody, and they can just open in a browser, and the whole chart is embedded in that URL without any other permissions or any other sharing stuff necessary to set up. You can also get that. Not your. I mean, the Vega editor is just a general service that's always running. So it opens in the Vega editor by default. Which is,
Yeah, that's just like a website.
Yeah.
This is how I think of it.
yeah. So that's not something you want to do for anything sensitive. But if you want to automate stuff, we also have this chart2URL method that does the same thing, that builds up the URL that you can click on to open your chart in the Vega editor. So that lets you automate it. You could save it to a file if that was useful workflow for you.
Is there a way to run the Vega editor on a local server? Is there some instructions for doing that if we really wanted to?
I don't know if there are instructions for doing that. I haven't looked at that in detail.
It's like at my organization, probably that's what we would need to do.
Yeah, no, that's
Having it go out to your
that.
guys.
Sure. No, that would be interesting. Yeah, I haven't worked on the editor that much.
I've opened Vega editor just on my computer.
Okay.
I don't know if that's something different, but like for trying to test changes in Vega-Lite, I feel like I've run Vega editor just
Yeah.
on my computer.
Like localhost? Okay.
Yeah, I think. Yeah, you can host it. Yeah, I just don't know all the implications of what you need to set up. So like this URL you need to change. which isn't something we have like a easy way right now to like change the space URL, but that's something that we could. No.
There was a question earlier during one of the exercise parts that about a broken Open and Vega editor link in VS Code. I can't remember who asked me.
Oh, yeah.
So maybe this to URL would be a better answer. Than
Yes.
I
So
suggested for that.
actually, there's an even better answer
Okay.
that was added for VS Code users because so that for reasons I don't fully understand, this Open and Vega editor does not work. This link does not work in VS Code. It won't open your browser. So a way to do the same thing when you're working locally is to use this chart.openEditor method. Whoops. This will only work when you're working in a local environment. This won't work in a cloud environment, so it doesn't work here in Nabari. But that will basically do the to URL conversion and open the chart in the Vega editor in one shot. It uses the Python web browser module to open your web browser with that URL. So that's the interactive part of things. If you want to share interactive versions of your charts.
I thought of one caveat that has come up for me before with interactive charts, which is I think on mobile they usually don't work. So like if you're sharing an interactive chart with students or something and they're all looking at it on their phones, I don't think it usually works in my experience.
What part?
Just like clicking, that kind of thing.
Okay, Chris's comment was some of the interactive behaviors don't work as well on mobile.
Yeah, it's just
Right now.
somehow the way that telephones handle those JavaScript events is different.
All right, and then we have pretty nice support now for static image export. This is something that's much easier in version 5 of Altair compared to older versions, because now there aren't any like system dependencies required to do this kind of thing. So you can do chart.save to PNG, SVG, and PDF, and these all just work. This under the hood is using a library called VL-convert that I wrote that actually embeds a JavaScript runtime into this Python library, so it's fully self-contained. It doesn't rely on like Selenium, doesn't rely on like a system web browser and all those things that are hard to get working. So this is pretty seamless way to do these exports to PNG, SVG, and PDF. There are options that we won't go into in detail, but systems for publishing like Quarto and JupyterBook have support for Altair if you want to include Altair charts as part of a larger like book or document structure. The PDF export workflow is a nice approach for embedding Altair charts in LaTeX typesetting kind of documents that work well with PDF format, because then you get the vectorized version of the chart embedded. There are a bunch of dashboard toolkits that support Altair. Jupyter Chart is the one that's built into Altair, and it works with the dashboards that support Jupyter widgets. But there's a bunch of others that also have different support for Altair, and a lot of them have support for accessing the selections from Python, the way that I showed with Jupyter Chart. So there's support in Panel and Dash, several others here. So if you're interested in using a dashboard toolkit, check out what support they have for Altair. We're not experts on all of them, but we can happy to talk with you about options there. And that is the end of the tutorial content. So for the last half hour here, you have the option of looking at the exercises for part 3 for interactivity, or looking at basically just practicing this idea of sharing a chart with somebody else. You could share it with someone next to you, you could share it with one of us, and work through just if there's a format that is useful to you in your work, see if you can convert a chart into that format. So, and we'll be here walking around.
And we know 4 hours is a long time to concentrate, so I feel bad if anyone needs to go.
And just another reminder, here's the here's the location of these notebooks on GitHub. This includes all the notebooks we went through today, and setup instructions if you want to use these locally and not through Nabari. So I'll leave this up here if you want to check out the original notebook repository.
So is it, we can't quite read it, is it just
Oh.
GitHub/Vega?
Yes. Oh, well.
Yeah, GitHub/Vega/Python.
Okay.
Yep.
And once you get to Vega, we should be able to find it. I'd say just go to github.com/Vega and then we can find it. And then probably repositories. I think we found it. That was like the hardest question. Yeah, but there is, it turns out there is another repository called Altair Tutorial. Oh, so that was causing some confusion. And I don't know if there's any real benefit to like saving the worked through ones. Do you have an opinion on that? Like saving the things we just created?
I don't think the ones that we created are that useful.
Yeah.
But if folks want to download their like
Right.
versions of exercises and things from where is it?
Download.
Download, there we go. So if you want to save your versions of these notebooks that you've been editing during the tutorial, from within JupyterLab and Nabari, you can right-click and download the notebook to keep it locally if you want. But the original versions of all of these are in the GitHub repository.